In this project, I'm building a PowerShell Detection Engineering lab using Sysmon, Splunk, Sigma, and MITRE ATT&CK. I'll collect Windows telemetry, search the logs in Splunk, write Sigma detection rules, build a dashboard, and map the results to MITRE ATT&CK. In this phase, I'm generating safe PowerShell activity. These simulations are harmless and are only used to create logs for detection practice. I'm running safe simulations that represent behaviors like obfuscation, system discovery, file creation, and outbound connection testing. These files show that the simulation created safe output on disk, which Sysmon can capture as file creation activity. After running the simulations, I'm checking the Sysmon operational log to confirm that Windows activity was captured. Here, I'm reviewing key Sysmon event IDs. Event ID 1 shows process creation. This helps identify when PowerShell or another process starts and what command line was used. Event ID 3 shows network connection activity. This is useful because PowerShell making outbound connections can be suspicious depending on the context. Event ID 11 shows file creation. This helps confirm when the simulation created files on disk. Next, I'm setting up Splunk to collect my Sysmon logs. First, I'm creating a dedicated index called Sysmon Lab so the Sysmon data stays organized and separate from other logs. After the setup, I'm verifying the events are flowing into Splunk by searching the Sysmon Lab index and confirming the Sysmon source and source type appear in the results. This search confirms that events were coming into the Sysmon Lab index. Next, I'm confirming that PowerShell-related Sysmon events are searchable in Splunk. I can see the event time, host, event ID, and raw Sysmon data. This helps verify that the ingestion worked and prepares the data for detection searches in the next phase. Next, I'm grouping the Sysmon logs by event ID in Splunk. This gives me a quick view of what types of activity were collected, like processes, network connections, file creation, and registry activity. Next, I'm pulling PowerShell activity into a cleaner Splunk table so I can quickly review the command line, process path, user, and parent process. I've installed Python so I can use the Sigma command line tool. This will let me write Sigma rules and convert them into Splunk detection searches. Sigma CLE is now installed and working. Next, I can use Sigma to write YAML detection rules and convert them into Splunk searches. YAML is the file format I'm using to write Sigma detection rules. It keeps the rule readable and structured with sections for the title, log source, detection logic, false positives, severity level, and MITRE ATT&CK tags. I'm creating my first Sigma rule in YAML format. This rule looks for encoded PowerShell command flags, which can be used to hide command activity. The rule includes the log source, detection logic, possible false positives, severity level, and MITRE ATT&CK mapping. Next, I'm creating a second Sigma rule for suspicious PowerShell execution flags. This rule looks for command line options like no profile, non-interactive, hidden window execution, and execution policy bypass. These flags can be legitimate, but they are also commonly seen in suspicious PowerShell activity, so they are useful for detection, testing, and tuning. This rule looks for PowerShell being launched by suspicious parent processes, including W, script, C script, MSHTA, reg server 32, and run DLL 32. So now I've used PowerShell to run Sigma CLE and convert my Sigma YAML rules into Splunk SPL. This shows that the detection rules I wrote can be translated into Splunk searches and used inside Splunk. I've created 3 Sigma YAML rules for PowerShell detection, encoded PowerShell execution, suspicious execution flags, and PowerShell launched from suspicious parent processes. I'm showing the rules folder to confirm that all 3 Sigma YAML detection rules were created and saved in my project directory. Now I'm building a Splunk dashboard. The goal is to take the Sysmon data I collected earlier and turn it into something easier to review. First, I'm adding a panel to count the total number of detection-relevant Sysmon events in the lab. The first panel gives me a quick overview of how much Sysmon data was collected for this lab. I'm counting key event types like process creation, network connections, file creation, and registry activity. The number is pretty high because Sysmon captures normal system activity too, not just my lab activity, but it gives me a good starting point for the dashboard. Next, I'm breaking the Sysmon data down by event ID so I can see what types of activity were collected. This panel shows how many events were collected for each Sysmon event ID. Event ID 1 is process creation, and that has the highest count because Windows constantly starts and manages processes in the background. Event ID 3 shows network connections. Event ID 11 shows file creation, and Event ID 13 shows registry activity. This helps me understand what kind of telemetry I have before I start looking deeper into the PowerShell activity. Next, I'm adding a panel focused on PowerShell process activity. This panel shows PowerShell activity in a cleaner table, so I can quickly review the time, user, command line, and parent process without digging through raw logs. Next, I'm adding a panel for outbound connections from PowerShell. Here I can see PowerShell made an outbound connection to an external address over port 80, which is normal web traffic. This doesn't automatically mean it's malicious, but PowerShell normally isn't used for web traffic, so it's worth taking a closer look. Next, I'm adding a MITRE ATT&CK coverage panel so I can connect the activity from my lab to real attacker techniques. This helps show what behaviors my detections are covering instead of just showing raw event counts. This panel shows which MITRE ATT&CK techniques appear in my lab data based on the detection logic. Most events fall under Other because Sysmon collects a lot of normal system activity too. The important part is that I can still see mapped techniques like registry queries, suspicious parent processes, file transfer activity, and web protocol activity. Finally, I'm adding a severity over time panel so I can see how the lab activity is grouped by priority. This panel shows severity over time using simple lab-based logic. In this dashboard, outbound PowerShell network activity is treated as high severity, suspicious PowerShell flags are treated as medium severity, file and registry activity are treated as low severity, and everything else is informational. Most of the events here are informational, which makes sense because Sysmon collects a lot of normal system activity too. This panel helps me separate high priority activity from background noise. Now that the Splunk dashboard is built, I'm going to verify the MITRE ATT&CK mapping. This step is important because I don't want the dashboard to just show random labels. I want each detection to connect back to a real attacker technique documented by MITRE. For this lab, encoded PowerShell maps to T1027, which is obfuscated files or information. Suspicious PowerShell execution maps to T1059.001, which is PowerShell under command and scripting interpreter. Outbound PowerShell connections map to T1071.001, which is web protocols. File transfer or file creation activity maps to T1105, ingress tool transfer. Registry activity maps to T1012, query registry. Now I'm connecting that evidence to MITRE ATT&CK so the activity is tied to real-world attacker techniques. This panel shows PowerShell process activity in Splunk. I mapped this to T1059.001 because MITRE classifies PowerShell abuse under command and scripting interpreter PowerShell. This panel shows PowerShell making an outbound web connection. I mapped this to T1071.001 because attackers may use web protocols like HTTP or HTTPS for command and control communication. And this panel summarizes the MITRE ATT&CK coverage for my lab. I'm using detection logic to group Sysmon activity into known attacker techniques. To quickly recap, I started by using Sysmon to collect Windows activity logs. Then I brought those logs into Splunk using the Sysmon lab index so I could search and analyze them. After that, I extracted PowerShell activity from the raw logs and created Sigma detection rules in YAML format. I also converted those Sigma rules into Splunk SPL, which shows how the same detection logic can be used in Splunk. Then I built this Splunk dashboard to organize the results visually, including event counts, PowerShell activity, outbound connections, MITRE coverage, and severity over time. Finally, I used MITRE ATT&CK Navigator to show which attacker techniques this lab covers, such as PowerShell, obfuscation, web protocols, file transfer, and registry queries. So overall, this project shows the full detection engineering workflow: collecting logs, searching the data, writing detections, building a dashboard, and mapping coverage to MITRE ATT&CK. The full report is available on GitHub, along with screenshots, notes, and project documentation for anyone who wants to review the full project.